Hello everyone, so welcome to the class 12th board series. इस वीडियो में we will be discussing about alcohols, phenols and ethers. So make sure you have liked the video because to be honest it takes around 3 hours to make this video, printing the material, making the PDF yourself. So let's get started with it. So in the first part, that is in this video, I will be discussing the alcohols and phenols. In the second part, that is the second part of this video, that is further in this video I shall be discussing about ethers. So alcohols and phenols कब form होते हैं? When a hydrogen atom in a hydrocarbon, aliphatic or aromatic, is replaced by a hydroxyl group. Very basic. I shall be taking the classification से start करेंगे. We'll go on till the last part of the chapter, that is the ethers. सब कुछ cover होगा. After watching this video, you don't need to read the NCERT or any other book for this chapter. So classification of alcohols is done as primary, secondary and tertiary alcohols. Let me tell you with the help of an example क्या होता है. If we have this carbon which is attached to two hydrogens and one alkyl group which can be CH3, ethyl, कुछ भी हो सकता है, then this type of alcohol is known as a primary alcohol which can be also known as a 1 degree alcohol. Similarly, अगर मैं इस कार्बन को 2 R से अटैच कर देता हूँ, that is this carbon is attached to two other carbons, this hydrogen is here, this OH is here, this is known as a secondary alcohol or a 2 degree alcohol. Similarly, if I attach this secondary and replace this hydrogen by another alkyl group, तब मैं इसको बोलूँगा tertiary alcohol or a 3 degree alcohol. Now alcohols can be monohydric which contains one OH, like this is a monohydric alcohol because it contains one OH. It can be dihydric which contains two OH groups and polyhydric which contains 3 or more OH groups. Like in phenols, you should understand a very important example. First of all, what is a phenol? This compound is known as a phenol. Now what I do is that if I attach one OH group to the ortho position, जब ऑर्थो पे एक और हो जाता है, इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग इज देयर, दिस थिंग इज कॉमनली नोन एज catechol. Please remember that these type of questions are asked regularly in BITSAT examination. Okay, so you should know that whenever the OH group is attached at ortho, meta or the para position, क्या difference आता है nomenclature में? This is known as resorcinol. Similarly, if I take the OH to be present at the para position, intermolecular hydrogen bonding is present, not intramolecular, intermolecular. This compound is known as quinol or hydroquinone. Okay, now you can see from here that this carbon which is attached here is sp2 hybridized, which has been written here. These can be monohydric, dihydric, polyhydric. You can attach any number of alcohols you want. Okay, the dihydric phenol can be classified as ortho, meta or para position ones. In allylic alcohols, the OH group is attached to sp3 hybridized carbons but next to the C double bond C. What is meant by allylic alcohols? Allylic are very important. Like for example, I have written this CH2 double bond CH, CH2OH. So this thing is known as an allylic alcohol. Vinylic isn't possible because that can tautomerize into formation of aldehydes, but this is possible because this is an allylic alcohol. It is attached to sp3 hybridized carbon. Okay, so this can be also known to you. Now moving on to the structure of the alcohols and phenols, please note that the oxygen atoms of the alcohols is sp3 hybridized. Let me say ये oxygen है, whatever this is here. You can see that this is sp3 hybridized, 2 lone pairs plus 2 sigma bonds, and these can have the tetrahedral position of the hybrid atomic orbitals. Please understand the difference which I want to tell you from inorganic chemistry. Geometry and shape are two different things. Geometry is defined by the steric number, that is the summation of sigma bonds plus lone pairs. Okay, that will be fixed. Like for steric number is equal to 4 lone pairs, 2 lone pairs plus 2 sigma bonds, the steric number comes out to be equal to 4. So that will be sp3. The geometry will be tetrahedral, but the shape will be different because shape varies with the number of lone pairs which are present due to the repulsion. Okay, so in phenols, the OH group is attached to sp2 hybridized carbon and thus the CO bond acquires a partial double bond character. Very simple thing, this is known to you. Resonance जो होता है, that is responsible for the partial double bond structure. Now what you can see, ऑक्सीजन के पास क्या है, ऑक्सीजन के पास लोन पेयर है, so that can show the plus M effect. So how to draw the resonance structure? This lone pair goes from here to here, this comes onto this bond. So क्या होगा मेरे पास यहाँ पे, इसने इलेक्ट्रॉन डेंसिटी दी है, so this becomes electron deficient, getting a plus charge which has been written here. This electron density is placed onto this carbon, so यहाँ पे मेरे पास negative charge बन जाएगा and this will be formed. You can draw the other resonance structures if you want, like इधर से इधर गया, इधर से इधर आया. The thing to note here is that this double bond is formed, which is a partial double bond, because in some of the resonance structures this is a single bond. So that is why this is known as a partial double bond, because the bond order is not equal to 2. That is the logic. Bond order 2 नहीं आता है. That is why this is known as a partial double bond. Okay. Now let us move on to the next one, that is the nomenclature of the alcohols and phenols. Not very important because class 11th में अच्छी तरह पढ़ाया जाता है. So in IUPAC system, the alcohols or alkanols are named by replacing the last E of the corresponding alkane by ol. Like for example, let me take the aromatic thing here. We have CH3, we have OH. Now first of all तुम्हें decide करना है कि number 1 किसको देना है. Now think, OH is more acidic than CH3. That is the basic logic which we use. So number 1 would be given here, number 2 would be given here, and the rest wouldn't matter. So this thing is known as 2 के पास क्या है, 2-methyl phenol. Okay, so that is how the basic nomenclature is done. One more example for you to prove the importance of the long chain, which should be known to you from class 11th. Okay, now you can do, first of all, number 1 तो समझ आ गया, number 1 इसको जाएगा. That number 2 इसको जाएगा, number 2 would be given here. Instead of going from here to here, we will go from here to here. Why? Because we need to give the minimum number. So we have 1, 2, 3, 4, 5. This order would be the correct in this particular case. Okay. So what we get from here? मेरे पास 2 and 4 पे methyl है. 2 methyls are there. So we get 2,4 dimethyl. Now this thing is a cyclopentane. Pentane लिखो. Last E जो होता है, जो यहाँ पे E होता है, that is replaced by all. So इसको E को replace करके OL लिख दिया. So this is 2,4-dimethyl cyclopentanol. Okay. Now let us move on to the very important preparation of alcohols. First method is from alkenes. उसमें भी first method है acid catalyzed hydration in accordance with the Markovnikov's rule. This is very important. So this is one of the reactions which I am taking as an example. Please understand that the steps are very important as given in the NCERT. So I'm taking the steps also. So this is a reaction which has been given to you. इसमें ये form होता है. Let us try to understand the mechanism here. So protonation मतलब क्या होता है? Addition of H plus basically. Okay, so what will happen from here? H plus is electron deficient. H2O is electron rich. So H2O which has a lone pair इसलिए electron rich है. Plus H plus would give me the formation of H3O plus. Okay, now what would happen from here? We have CH3, CH double bond CH2 plus H3O plus. Basically, if you want, you can attack directly the H plus, but since in the NCERT it has been given, we need to use H3O plus only. So what will happen from here? Electron rich, electron deficient, both will react, giving me the formation of CH3, CH, and the carbocation would be formed here, and here we have CH3 plus H2O. Basically क्या हुआ है? H plus ने reaction किया. H plus has done the reaction. This would react with the H plus because this is electron rich. So what would happen? Plus charge would go to the more stable secondary carbon instead of the primary carbon. So plus charge को मैंने secondary carbon पे दे दिया and H would go to the primary carbon, giving me the formation of CH3. So the first step is done, that is the protonation. Now the second step is the nucleophilic attack. Nucleophile मतलब क्या? Electron rich. So you can see we have CH3, CH plus CH3. Electron rich क्या है? H2O which has a lone pair on oxygen, that will go and attack this thing, giving me the formation of CH3, CH, CH3, O, H and H plus. So we have got the formation of this particular thing which I have written. The next step is the deprotonation of this thing to form an alcohol. Deprotonation means the removal of H plus. So H plus कैसे remove होगा? H plus will be removed plus and H will be removed, giving me the formation of CH3, CHOH, CH3. So this was the required product, as you can see from here. So that is finally formed. So this is the first method. The second method is the hydroboration oxidation. So B2X is basically diborane. Okay, as taught to you in class 11th P block. This can be written as BH3 whole twice, and BH3 can be written as BH2H2 whole twice. Okay, so B2H6 को मैंने बस ऐसे लिखा है, not a big deal. Now the first step is you need to attack the HBH2 here. So what I'm going to do is that HBH2 I'm writing here. Now why in this form, why not BH2H? Because BH2 is more crowded. That would likely to go to the less crowded position. Okay, so this bond from here moves along here in order to join here. This bond moves along here, giving me the formation of CH3, CHH, CH2, BH2. So I'm writing BH2 once again as BHH. Now you can guess what I'm going to do once again. I'm going to take the mole of alkene once again. So what would I get from here? Let me write CH2 double bond CH, CH3. I'm writing the mole of alkene once again. So what would I get the formation? This bond moves here. This bond moves here. Okay. So once again I would get the formation of CH3, CH2, CH2 whole twice, because अबे दो जुड़ने वाले हैं यहाँ पे, and we have B and H. So once again you can guess यहाँ से क्या होने वाला है मेरे पास. Once again the same reaction would occur with 1 mole of alkene. So let me write CH2 double bond CH, CH3. So you can guess from here that we need 1 B2H6 reacts with 3 moles, will give me the 3 moles of formation here. Okay, so here I would get the formation of CH3, CH2, CH2 whole thrice, you can guess, and boron, because of hydrogen to bachega nahi. So now further it cannot react because further hydrogen isn't present for the reaction with the alkene. So what would happen from here? I react this compound with H2O2 and NaOH. So what we have taken? H2O2 and a basic medium. So what would happen from here? This B is removed, giving me the formation of 3 moles of alcohol, 3CH3, CH2, CH2OH plus ये जो B है, that will react, giving me the formation of BOH whole thrice. So this is the important product. This is known as hydroboration oxidation, giving me the formation of an alcohol from the double bond. So now let's move on to the next part, which is from the carbonyl compounds, the very important reduction of aldehydes and ketones. So if I have taken an aldehyde, RC double bond OH plus H2 along with palladium, platinum or nickel, we get the formation of RCH2OH, which is basically an alcohol. Similarly, if I have taken this ester here, I take LiAlH4, it also gives me the formation of 2 moles of alcohol. This will be dealt properly in the carbonyl compounds chapter. If you want, it is very clear, H minus aayega, that will go react, this comes back here, takes this out, giving me the formation of R-O minus, H2O lenge, R-OH and RCH2OH. Okay, so that is the basic logic which we are using. It will be discussed in the carbonyl compounds, but very important reactions for the preparation. Now aldehydes yield primary alcohols. You can see this alcohol is a primary alcohols, whereas if I had taken a ketone here, अगर मैं यहाँ पे ketone लेता, तो this would be RC double bond O R dash. I would have got the formation of RCH OH R dash. So this is a secondary alcohol because this carbon is attached to 2 different groups. Even they are the same, then also secondary only because this carbon is attached to 2 more carbons. Okay, so ketones give me secondary alcohols when subjected to reduction. Okay, I hope that this point is clear to you. Next we have the reduction of carboxylic acids and esters. Esters का मैंने यहीं पे discuss कर लिया. We have discussed aldehydes, we have discussed ketones, all the functional groups are getting discussed. Carboxylic acid, once again you can guess, same. So we have RC double bond O, OH, I take LiAlH4 and water, it once again gives me the formation of the primary alcohol. Please remember that LiAlH4 is a better reducing agent than NaBH4, which will be discussed in carbonyl compounds, but for information this should be known to you. Next we have by Grignard reagent. Let me say we have in a carbonyl group which has been given to us. We take R MgX, which is known as a Grignard reagent. Please note that this is a covalent bond, but for simplicity we can write this as R minus Mgx because the negative delta charge is on R only, so that is why we can write it as R minus in order to simplify the answers. So what will be happening from here? R minus jayega, this will attack from here, this bond goes along here, giving me the formation of O minus here. Now we take H2O, so H plus will go and join here, giving me the formation of an alcohol. Okay, so this reaction basically produces a primary alcohol with methanol. Methanol, okay, first of all you need to understand that it is methanol. I'm sorry for that, because if we have HC double bond O, H, if I take R MgX H2O, you can guess R minus ने attack किया, क्या बन जाएगा मेरे पास? R CH2OH. So this is basically, you can see that we have the formation of primary alcohol. This is the primary alcohol. If I have taken an aldehyde except methanol, that is RC double bond O H plus R minus MgX along with H2O, it would have given me the formation of RCH2OH. RCH2ROH. Okay, because this R is present here. So you can see that this is a secondary alcohol which is formed. In the first case we would have got the primary alcohol. And if I would have taken a ketone, that is RC double bond O R dash plus R minus MgX, I would have gotten the formation of RCROH R dash. So this is a tertiary alcohol which is formed. Okay, so I hope that this point should be known to you. Next one is the hydrolysis of the alkyl halides. First of all, we have Rx plus KOH, that gives me ROH. How? This minus, this would go, take out this, giving me the formation of ROH. Now, to avoid dehydrohalogenation, we take mild alkali. What is dehydrohalogenation? I have discussed in the haloarenes and haloalkanes, the previous video thi. So what actually happens is that, let me say we have RCH2X. Okay, this is hydrogen. If I would have taken a stronger base, then dehydrogenation removes HX, giving me the formation of alkenes. Okay, so that is why to avoid dehydrohalogenation, we use mild alkalis. Now, ease of hydrolysis is Ri, Rbr, Rcl and Rf. Now, why Ri is greater? Obviously, because Ri bond is easier to break because of the bond distance. Okay, and tertiary, secondary, primary alkyl halides. Next, we have the hydrolysis of ethers for the formation. So, let me say we have been given some ROR, that is an ether has been given to you. I take H2O in the presence of an acid. So, acid ki presence hai, we have oxygen which has a lone pair. So, basically we get the protonation and the lone pair attacks and this happens. So, basically what you can see from here, how to do the breaking of the bond. H goes here, OH goes here, R OH बन रहा है. Similarly यहाँ पे भी R OH बन रहा है. So you can see from here that we get the formation of 2 moles of an alcohol which is used for the preparation from the ethers. Next we have from the primary amines by treating with the nitrous acid. Okay, very important. We have RNH2, it would be discussed in the amines properly. We have HNO2. Now HNO2 क्या करता है? Please remember that it helps in the diazotization. What is that? That gives me the formation of N double bond N plus Cl minus from here. Okay. Now if I would have taken this, I take water also, then what happens is that this goes, attacks this thing here, this bond moves along here. So अगर मैं इस bond को उठा के यहाँ पे रखता हूँ, we get the formation of the nitrogen gas which is removed. Here we get the formation of ROH. So this method also helps in the formation of the ROH. Nitrogen is removed, one extra H from here, Cl minus gives me the formation of HCl. Okay, so you can see from here that ROH can also be formed from this method. Next we have by alcoholic fermentation. So basically what we do is that we take sucrose, we hydrolyze it in the presence of an enzyme which is known as invertase, directly taken from the NCERT. Please remember, it is very important. We get the formation of glucose and here we get the formation of fructose. Okay, so hydrolysis मुझे ये चीजें देता है. Now the second question is that now we have taken glucose and fructose which is present here. Okay, that is you can take any of these or both of these in the presence of an enzyme. Now my question to you is that mention in the comment section okay, which enzyme is used here. This is taken from BitSat. Please mention the answer in the comment section that which enzyme is used here. Okay, so we get the formation of this thing, that is ethanol is formed. So once again alcohol can be formed by the alcoholic fermentation. Now we move on to the preparation of phenols. Alcohols pura hua. Now we are discussing the preparation of phenols. So what I do is that I take chlorobenzene along with NaOH. So what does this give me? First of all, high temperature and pressure होना चाहिए because this bond is a partial double bond. So इसको break करना मुश्किल होता है. So high temperature and pressure gives me the formation of O minus Na plus. If I react this with H2O or HCl, whatever, I get the formation of phenol. So this is the one of the methods which is used for the preparation of phenols. Now benzene sulfonic acid. Now please remember this is a very important step. Benzene sulfonic acid is basically when we have a benzene which is attached to SO3H. Now here we take NaOH. So that gives me the formation once again of this kind of thing. So we get O minus Na plus from here. Now if I take H2O or H plus whatever, I get the formation of phenol from here. Very, very, very important reaction. Okay, now we have diazonium salts. I have told you diazonium salts क्या होता है? When we have N double bond N plus Cl minus, we take H2O heat. What will happen? This lone pair would go attack this. Nitrogen is released, giving me the formation of phenol from here. N2 gas will be released. H and Cl would give me formation of HCl. We move on to the most important part, that is preparation from cumene. So first of all, what is cumene? Very important from JEE advanced point of view also, this reaction mechanism I have discussed very clearly in my free videos. So this is cumene. If I take O2, now O2 will join by breaking this bond because this CH bond is the weakest. Now why this CH bond is the weakest? You can guess. Radical banao, you will get C. This is the weakest bond because whatever the intermediate, whichever intermediate is formed here, everything will be stable because of the resonance with the benzene group. Okay, so obviously this CH bond will be broken and O2 will join here, giving me the formation of this particular compound. Now the next reaction is very important but not from the NCERT point of view. What basically happens is that H3O plus है, so H plus आएगा, so इसको protonate किया, this is protonated, so we get H2O plus formation here. Water को remove किया, we get the formation of plus charge here. Now the phenyl shift. Phenyl shift is better than methyl shift. Told you multiple times. So phenyl shift happens from here. मतलब इसको shift करके यहाँ पे रखा. We break this bond, we get the formation of phenol and CH3 C double bond or CH3 is also formed. So this is the reaction which is used for the preparation of phenols. For the boards, only the reaction is necessary, not the mechanism. Next, we move on to the physical properties of alcohols. That is lower alcohols which have low molecular mass are colorless. Members from C5 to C11, that is from pentane to moving on to 11th one, are oily liquids and the higher members are solid because of the increasing molecular mass. The hydroxyl group in alcohols can form hydrogen bonds with water, so alcohols are miscible with water. The solubility decreases with the increase in molecular mass. Like for example, I have ROH which has been given to you. We take water, that is HOH, so you can form the hydrogen bonding which is present with water. Okay, but if the mass increases, you can see that this will prevent this one from attaching to the hydrogen which is present, so this hydrogen bond will decrease. So the thing has been written, solubility decreases with the increase in molecular mass. The boiling points of alkanes are higher than expected because of the presence of the intermolecular hydrogen bonding in the polar molecules. Like what actually happens is that, for example, if I would have taken these two compounds like OH and OH, one is present at the ortho position, one is present at the para position. So para wala ka zyada boiling point hoga because intermolecular hydrogen bonding is present, here intramolecular is present. Okay, next we move on to the physical properties of phenols. Alcohols का हो गया, phenols के बारे में. These are colorless liquids or crystalline solids but become colored due to the slow oxidation with air. Like in the labs, if you see, it is generally colored, but the pure one are colorless, okay, but when you place in the labs or in contact with air, they become colored. Phenol is also known as carbolic acid, very important point. Because of the presence of the polar OH bond, phenols form intermolecular hydrogen bonding with other phenols with water. So this step has been already mentioned. Let us move on to the important reactions of alcohols and phenols. The first one is the cleavage with the OH group, and let us discuss some acidity points. So the first point is I have taken alcohol, in the second one I have taken a phenol along with the sodium metal. So क्या होगा मेरे पास? I would get the formation of RO minus Na plus H2. So hydrogen gas is released in this particular case. So this should be known to you. A very important point, whenever alcohols or phenols, like you would see, react with sodium metal, they give me the formation of a salt along with the release of the hydrogen gas, as clearly mentioned in the mechanism. Now alcohols are weaker acids than water due to the plus I effect of the groups which are present, which decreases the polarity of the OH bond. Like we have HOH, here we have ROH. The R group is a releasing group. So when we form the -1 minus, -1 oxygen, here also we form -1 oxygen, R donates, which destabilizes the O which is present. So that is why alcohols are weaker acids than water basically. Acidic strength of alcohols, now this should be very clear to you. You can guess from this one that the primary alcohols will be more acidic than the secondary alcohols than the tertiary alcohols. Okay, so this point should also be known to you. Now this thing has been mentioned, electron releasing effect is there due to which this effect happens. Now order of acidity of the carboxylic acid is greater than the carbonic acid is greater than this phenol, greater than water, greater than alcohol. This has been discussed in the free videos. Very simple, how to decide the acidity? Remove the H plus, form the minus. Now see that where the minus is more stable, that will be more acidic. Like for example, this is R, C double bond O, OH, H plus remove kiya, so this will be formed. This is in resonance, so that is why it will be more stable. Okay, that is basic logic. Now phenol is more acidic than alcohols due to the stabilization of the phenoxide ion through resonance. Phenol है, उसका H plus remove किया, we get O minus, which is phenoxide. Now this minus is in resonance with the ring if you draw the structures, so that is why it is more stable than the alcohols, which has been clearly mentioned. Now presence of the withdrawing group increases the acidity of the phenol. Like for example, if I would have placed NO2 here, that will increase the acidity because this will withdraw. We have electron rich, we want to decrease the electron density here. So decrease करने के लिए क्या चाहिए मुझे? Withdrawing group. So that is the logic which I am using here. So thus the increasing order of acidic strength is this one. Now higher Ka and lower pKa values corresponds to a stronger acid. Like Ka कुछ X है, pKa basically is equal to minus log of Ka. So minus log of X. So that is why if Ka increases, pKa would decrease because of the minus sign. So higher Ka and lower pKa corresponds to a stronger acid. Next we move on to the very important reaction, that is the dehydration of alcohols. It requires an acid catalyst and the reaction proceeds by the carbonium ion. Let us try to see the reaction mechanism, which is the most important. So I have taken this tertiary alcohol, concentrated H2SO4 heat implies we have the presence of the acid H+. This has a lone pair which will donate the electron density, giving me the formation of this OH2 plus group. Dehydration matlab kya? Removal of water. So H2O is removed, giving me the formation of the carbonium ion or the carbocation. Okay. Last step is the removal of H+. So plus is present here. Take H from any of these carbons, we get the formation of this particular compound. So you can see that an alkene is formed on the dehydration of the alcohols. Okay, very important step. I'll be taking a very important reaction in ethers, जो भी आने ही वाला थोड़ी देर में, where we take ethanol that can also form the ethers and that can also form the alkenes on various temperatures. So that example would also be taken. Next we have the oxidation of the alcohols. Now oxidizing agents which are used are neutral acidic or alkaline KMnO4, any of these three can be used, and acidified K2Cr2O7. So first of all, oxidation hota kaise, you need to understand that. We have CH3, CH2OH. This compound has been given. If you oxidize this, that is, we introduce an oxygen, nascent oxygen, which is basically the oxidation process. So we get the formation of an aldehyde here. If you introduce one more oxygen, we get the formation of the acid here. So we can oxidize an alcohol to the acid with the formation of this reaction mechanism. Now if I would have taken a secondary alcohol, what would have happened? We have got CH3, CHOH, CH3. We oxidize it. So obviously this would be oxidized, giving me the formation of CH3 C double bond O CH3. Now on further oxidation, what will happen if you further oxidize this with acidic KMnO4? First of all, tautomerization hoga. Now how this is tautomerized? We have CH3 C double bond O CH3, so that can also be written as this compound here. Isko oxidation karo, oxygen introduce kiya, we get the formation of CH3 C double bond O OH plus now HC double bond OH can also be oxidized to HC double bond O OH, which can be further oxidized to CO2 plus H2O. Okay, so similarly you can also do the oxidation for the tertiary one. That would give you the same type of the answers which have been written here. Now a very important reagent, that is PCC, has been mentioned here. Please note that PCC is used as a selective reagent which oxidizes the primary alcohol to an aldehyde only. So aldehyde tak hi hoga. After that मेरे पास कोई oxidation नहीं होगा if I would have used PCC. So for example, we have been given a primary alcohol. If I would have used PCC here, I would have got the formation of an aldehyde only. That is, reaction यहीं पे stop हो जाता, आगे नहीं जाएगा. Okay, so that is very important. Next we have the dehydrogenation of alcohols. It basically means that we are using copper and heat is the reagent. Dehydrogenation मतलब removal of H2. Okay, hydrogen को remove कर रहा हूँ, so that is dehydrogenation. The temperature basically is taken to be 300 kelvins generally. Okay, so 300 degrees Celsius, I'm sorry, generally 300 degree Celsius. So for example, I have been given any compound, let me say we have been given R CH2OH. अगर मैं Cu heat कर रहा हूँ, dehydrogenation क्या करेगा? I would have R CHOH, removal of hydrogen should occur. So hydrogen remove karo. So I would get the formation of R CH double bond O and aldehyde would be formed. Similarly, secondary के साथ मेरे पास ketone बन जाएगा. Very simple. You have to just remove the H from OH, H and H from the adjacent one, giving me the formation. Okay. Victor-Meyer test is a very important thing. In this test, the primary alcohols give red color, the secondary alcohols give blue color, and the tertiary give no coloration. Okay, so this should be understood. Primary से red color आ रहा है, secondary give me blue color, and the tertiary give me no color at all. Next we move on to the reaction of the phenols, very important one. The first one is the electrophilic substitution reaction. Like, let's try to understand halogenation. So if I take phenol here, halogenation matlab we take Br2 in excess, we get the tribromination to be occurring. So क्या होगा? So मेरे पास bromination would occur at all the ortho and the para position, giving me the formation of 2,4,6 tribromophenol. Very important thing that whenever we take Br2 in excess in the basic medium, so or even in the presence of H2O, we get the formation of 2,4,6 tribromophenol. But if we want only the bromination to occur at one place, we take Br2 in CH2, CS2 or CHCl3, that is aprotic solvent is taken here. So I take Br2 along with CS2. So what would happen that only one position will be will have the reaction to occur. So in this case, we'll get the para position to be the major one. So this is the major product which will be formed in this particular reaction. Okay, so monobromination ke liye we use Br2 and aprotic solvent, but from tribromination we use Br2 with a protic solvent. Sulfonation, this is a very simple thing. We have been given a phenol. Sulfonation karani hai. We take concentrated H2SO4 we get the formation of the SO3H at the ortho position and at the para position. Okay, so this can be also formed here where the para will be the major one. Okay, next we have nitration. Please note that this is a very important thing. Nitration is done with the nitrating mixture, which is basically concentrated HNO3 and concentrated H2SO4, which gives me the formation of ortho para mixture. Okay, but what actually happens is that this thing would be formed when we had taken the dilute HNO3. So that is why this thing I am mentioning here. Whenever concentrated HNO3, concentrated H2SO4 is taken, we get trinitration to occur. So NO2 will be joined at all the ortho and the para position. So basically this will be formed according to the NCERT. But what actually happens is that we get the oxidation to occur. Okay, so this is formed in traces. Traces मतलब बहुत कम form होता है. But since in the NCERT ये दिया हुआ है, so this should be known to you that this thing will be formed, which is also known as picric acid. Please note the reagent concentrated HNO3 and H2SO4. Now if I would have taken the dilute HNO3 along with phenol, we would have got only one nitro group to be present at the para or at the ortho position. Now please note that the ortho and the para isomers can be separated by steam distillation. Before that, please understand the difference between the dilute HNO3 and concentrated HNO3. I hope that is clear. Now steam distillation में क्या होता है? The orthonitrophenol has, now see, orthonitro के पास होगा intramolecular hydrogen bonding, whereas this would be intermolecular hydrogen bonding. So obviously this will be less volatile, this will be more volatile. This is the association of molecules which makes the para-nitrophenol to be less volatile, but orthonitrophenol has intramolecular hydrogen bonding which makes it steam volatile, and hence these two can be separated by steam distillation. A very important point. Now let us move on to the very important reaction for this chapter, which is the Raman-Tiemann reaction. Now what happens in Raman-Tiemann reaction is that we have been given phenol, we take CHCl3 along with OH minus, which is a base. It gives me the formation of, see, first of all kya hoga, we get the formation of O minus Na plus, and here we have CHCl2. So this will be formed. Now we take the base once again. Base kya karega? This OH minus would go substitute this Cl. So we get two OH formation on a single carbon, which is unstable. So we would get the formation of the aldehyde onto this carbon. So यहाँ पे aldehyde बन जाएगा, giving me the formation of C double bond O H, which has been written here. इसके बाद क्या होगा? We take HCl. So HCl लिया, so H plus जाएगा, giving me the formation of this ortho product as the major one. A very important reaction which should be known to you. Okay, reaction mechanism is not important for boards, but you should remember that carbene is an intermediate. Okay, अगर JEE advanced की वीडियो होती, I would have obviously discussed all the mechanisms, but since we are discussing about boards only, so let's stick to that level. Now we have the coal-base reaction. What happens in the coal-base reaction? We take phenol, which has been given to you. We take NaOH. So NaOH क्या करेगा? Once again, H plus will be extracted, giving me the formation of O minus Na plus. Now we take CO2 in acidic medium. It gives me the formation of OH here, and from here we'll get the formation of the acid. Reaction mechanism is very simple. What actually happens is that resonance structure banao. When the negative charge comes here, that goes and attacks this carbon, giving me the formation of this compound to be formed. We have the reaction with the zinc dust. Zinc dust क्या करता है? If I would have taken phenol, I take zinc dust, it gives me the removal of the OH. Basically what you can understand is that Zn and O react. So basically Z and O separate हो गया. This hydrogen attaches here. So basically the benzene is formed once again. So basically phenol along with zinc dust gives me the formation of benzene. Next we move on to the oxidation of phenols, which can be done by Na2Cr2O7 in the acidic medium. So what actually happens from here is that how the oxidation occurs. See, first of all, we would have the formation of this compound, which is known as benzoquinone. Now the people who would have following me on an academy for the JEE advanced level videos, They know that this compound is used in the preparation or in the Diels-Alder reaction as a dienophile. Very, very good dienophile it is. So it is used in the Diels-Alder reaction. Next we have the Fry's rearrangement. We have taken this compound, which is an ester basically. We take AlCl3, it gives me the formation of phenol along with C double bond of CH3, which is rearranged. Similarly, it can also be rearranged to the para position, which has been mentioned. So ortho or para can be formed. The most important point to note here is that the Fry's rearrangement is intramolecular reaction. So basically, अगर मैं तुम्हें दो compounds भी देता हूँ, so the reaction would be happening intramolecularly and not with each other. Okay, so this is the Fry's rearrangement. Now let's move on to the ethers. We have discussed alcohols and phenols properly. Now that last part is ethers. So ethers are the organic compounds in which two alkyl or aryl groups are attached to a divalent oxygen. Okay, this is the divalent oxygen, and first of all you can also note that these can also present the metamerism. These are represented by the general formula ROR dash, where R may be alkyl or aryl groups. Okay, so basically this is a symmetrical ketone, this is unsymmetrical or mixed ether. Not a ketone, this is an ether basically. This is a mixed ether, this is a symmetrical ether. So how to name this? We have methyl, methyl. So basically it will be known as dimethyl ether. Okay, and this thing is known, this is a mixed methyl, ethyl. So the thing which comes first is ethyl, because E comes first then methyl. So basically this would be named as ethyl, methyl and ether present here. So ethyl, methyl, ether. Okay. Now these are functional isomers of alcohols, very basic point. These can also exhibit chain isomerism and metamerism. How metamerism? I have told you multiple times on the free videos also that break along the functional group. If we have the same number of carbons, like here we have X carbons, in another example X carbons, here also let me say Y carbons. So if you change the position of the oxygen, we get some, let me say, X minus 1 and Y plus 1 carbons, which are different obviously. So these will show the metamerism. Okay. Now nomenclature of ethers, how nomenclature is done. So in IUPAC system, ethers are regarded as alkoxy alkanes in which the ethereal oxygen is taken along with the smaller alkyl group. Smaller alkyl group implies methyl in this particular case. And the bigger alkyl group is regarded as a part of the alkane. So alkoxy, इसमें कैसे करूँगा मैं इस वाले example में, try to see. Smaller ether, smaller thing is known as alkoxy, so basically methoxy. बड़ा वाला को हम alkane बोलेंगे, so methoxy ethane इसका नाम होगा. So that is how the ethers are basically named. Now we'll be dealing with the preparation of ethers. So if would have taken the alcohol at 413 Kelvin along with concentrated H2SO4, that is the lower temperature, I get dehydration to occur. Okay, that is basically the removal of water to form ethers. Now how that actually happens is that we have been given ethanol, we take one more mole of ethanol, we remove the water from here, giving me the formation of this ether. Okay, so diethyl ether is formed here. But if I would have taken the concentrated H2SO4 at 443 Kelvin, that is the higher temperature, protonation happens here, giving me the formation of plus charge. Okay, and finally the H plus is removed, giving me the formation of CH2 double bond CH2. So you can understand the difference that this I have already discussed in the dehydration, that whenever we have concentrated H2SO4 at a lower temperature, that is 413 Kelvin, we get the formation of an ether. But if we take the concentrated H2SO4 at 443 Kelvin, we get the formation of an alkene. Now we move on to the very important reaction, that is the Williamson synthesis. Only primary alkyl halides when react with sodium alkoxide give ether, while tertiary alkyl halides give alkenes due to steric hindrance. So first of all, let us deal with the primary one, which is the easier case. So first of all, what actually happens is that we have been given CH3, CH2Br, which is a primary alkyl halide. I take CH3, CH2O minus, Na plus. So what actually happens from here, you can clearly guess it. This O minus would go attack this carbon. This Br is removed from here. So I get the formation of CH3, CH2O, CH2, CH3. So you can see that we get the formation of an ether when we take the primary alkyl halide. But if we would have taken the tertiary alkyl halide as represented here, so what is the reaction which is going to happen? It is very crowded. You can see this carbon is very crowded for the attack to occur here. So what actually happens is that this CH3 can be written as CH2H. This minus goes, attacks this hydrogen. And this bond from here moves along here. So isko shift karke yahan pe rakho, we get a new double bond formation. This alkyl halide is removed. So basically you can see that we get a double bond formation. So we get CH3, CH3 double bond CH2. So an alkene will be formed whenever the tertiary alkyl halide is taken. Usme ether nahi banega, but we get this formation because of the crowding which is actually happening. Physical properties of ethers. Ethers are polar but insoluble in H2O and have low boiling point than alcohols because ethers do not form hydrogen bonds. Okay. Structure of ether, very simple, sp3, and it's V-shape because two lone pairs on oxygen. Very important reaction, that is reaction with HX. So this is the first question. 2 moles of HI दिया है, उसके साथ ether क्या करेगा? So HI basically implies H plus I minus. So lone pair from here will go and react with the H plus which is present. This is the question number 1. So what actually happens from here is that we get CH3O, CH2, CH3, protonation हो गया यहाँ पे. So this would happen from here. Now we have I minus which is also present. So I minus is a bulky group that would like to attack from the position which is less bulky. So left hand side less bulky है और right hand side is less bulky. The left hand side is less bulky because एक CH3 है सिर्फ. So it will go attack from here. This bond will move here. So I'll get the CH3I formation here. So CH3I formation happens from here and here I'll get CH3CH2OH. So plus CH3 CH2OH will be formed. 2 moles of HI. So you can guess इस वाले के साथ भी वही होगा. HI react करेगा 1 more mole which is present in the similar manner, giving me the formation of CH3 CH2I from here and CH3I तो पहले से ही present है. Okay, so this will be formed here. But it totally changes when we have tertiary kind of carbons. So what happens in that case? So what actually happens is, first of all, we'll get the oxygen to be protonated with the hydrogen. So we get the formation of this compound here. Okay. Now you would be guessing that I minus would attack, but in case of the tertiary carbons to be present, the carbocation is very stable in nature. So carbocation stable हो रहा है. So what actually happens is that this bond breaks to go onto here, giving me the formation of carbocation. So we get the formation of carbocation here and CH3OH will be formed. Now this will be reacting with the I minus from here, giving me the formation of this tertiary alkyl halide. Okay, so very important step. We have the electrophilic substitution, which is the last part of the chapter. In the ethers, OR is ortho para-directing group and activates the aromatic ring towards electrophilic substitution reaction. It has a lone pair, so it activates the ring, showing the plus M effects at the ortho and the para positions. Okay, but the para position will be more electron rich because the minus I which is shown is greater for the ortho position in comparison to the para position. So para will be the major products in the reactions. So Br2CS2, what does it do? Monobromination. So monobromination karo, the para will be the major product. Friedel-Crafts acylation. What we get the formation of an intermediate, which is this compound. So electrophilic substitution hoga at the para position, giving me the formation of OCH3 and C double bond O CH3. Now here we have CH3Cl, AlCl3, so we get the formation of CH3 plus. Okay, so CH3 plus will be reacting at the para position, giving me the formation of this compound which I have written here. So this completes the chapter alcohols, phenols and ethers. Please let me know your reviews for the video. Also mention the answer of the homework question. Please don't forget to like the video. It takes a lot of efforts in order to make these board videos. So thank you and all the best.